right, so 8.3, we're continuing with our sequences and series, but we're going to look at another type of sequence, which is the geometric sequence. So geometric sequence is something like 2, 4, 8, 16, 32. Do you notice the pattern here? We multiply by the same number to get from one number to the next. So here it would be times 2. So what was an arithmetic sequence? When you add to get from one number to the next. Geometric is when you multiply to get from one number to the next. So in a geometric sequence, we have a common ratio. We can find the common ratio, so what we're multiplying to get from one number to the next, by taking the second number and dividing it by the first. So if you notice in the example I did here, if we would have done 4 divided by 2, that'd give us 2, which was our common ratio. So you can just take the second number and divide it by the first. So the example I made up is actually our first example in A. What am I multiplying to get from one number to the next? 2. So our common ratio, or R, would be 2. Let's look at B. What am I multiplying to get from one number to the next? 3, perfect, times 3. If we don't see it right away, take the second number, 36, and divide it by the first. So it's simplified to 3. So our common ratio is 3. For C, what am I multiplying to get from one number to the next? Negative 1/3, awesome. If we didn't see that, we could take the second number, 1/9, divide it by negative 1/3. How would I divide a fraction in a fraction? Keep, change, flip. So change to multiplication, flip to 3/1. So this would be negative 3/9, which simplifies to negative 1/3. So if you don't see your common ratio right away, you're not sure what you're dividing, always just take the second term and divide it by the first. All right, next we're going to look at our geometric sequence formula. So that is a sub n is equal to a sub 1 times r to the power of n minus 1. So a sub n is the term that we're looking for. What's a sub 1? The first term. What is r? Our common ratio. What's n? The number of term we're looking for. So if it asks us for like the 10th term, n would be 10. So this is our common ratio formula. So add it to the list of formulas that you need to know for our test. Let's take a look at example 2. Let's write the first 5 terms of the geometric sequence whose first term is 3 and whose common ratio is 2. So we can plug that into our formula and come up with just our general formula for a geometric sequence. So what was a sub 1? 3. It's given. What's our ratio? 2 to the power of n minus 1. So this would be our general formula. Our first term was given to us already. We have a sub 1 is 3. To find a sub 2, I can plug in 2 into n. So I have 3 times 2 to the power of 2 minus 1. So this would be 3 times 2 to the power of 1, which would be what? 6. Awesome. Let's find a sub 3. So next we're going to plug in 3 into our n. So 3 times 2 to the power of 3 minus 1. This would be 3 times 2 squared. 2 squared is 4, and 4 times 3? 12. Next, let's find a sub 4. So 3 times 2 to the power of 4 minus 1. So 3 times 2 cubed. What's 2 cubed? 8. And what's 8 times 3? 24. And then lastly, let's find a sub 5. 3 times 2 to the power of 5 minus 1 would be 3 times 2 to the 4th power. What's 2 to the 4th power? 16. And 16 times 3? 48. So notice how, what was our common ratio? What was R? 2. So notice how we multiply times 2 to get from one number to the next for each term. All right, example 3. Find the 15th term of the geometric sequence whose first term is 20 and whose common ratio is 1.05. So let's plug in what we've got. For our general formula, I'm going to say a sub n is equal to, what's our first term? 20. What's our common ratio? 1.05 to the power of n minus 1. So this would be our general formula. What term is it asking us to find? The 15th term. So a sub 15 is equal to 20 times 1.05 to the power of 15 minus 1. So we can put this in the calculator. Make sure you follow your order of operations. You have to do the exponent first before you multiply that 20. Anybody have their calculator out? Bless you. So when you put it in the calculator, you should get 39.59. All right, example 4, we have to find a formula for the nth term of the following geometric sequence. And it says, what is the 9th term of the sequence? We got to come up with our formula and the 9th term. So let's start with our formula. A sub n is equal to, what's our first term, a sub 1? A sub 1 would be 5. Times, what would r be? 3. How did we know it's 3? Because we're multiplying by 3 to get from 5 to 15 and times 3 to get from 15 to 45. You could also check and see our second term divided by the first term would be 15 divided by 5, which is 3. So r is 3. To the power of n minus 1. So this is our general formula. Now which term is it asking for? The 9th. So we're going to find a sub 9. Which is equal to 5 times 3 to the power of 9 minus 1. What do we get? $32,805. Example 5. So it says the 4th term of a geometric sequence is 125, and the 10th term is 125 divided by 64. Find the 14th term, assume that the terms of the sequence are positive. So this is one of those examples where it doesn't give us the first and it doesn't give us the ratio. So we're going to use the formula to help us figure out what our ratio is first. So our formula is a sub 1. A sub n is equal to a sub 1 times r to the power of n minus 1. We were given a sub 4, which is 125, and a sub 10, which is 125 over 64. So we're going to solve this the same way that we did with our arithmetic sequence, where we weren't given our ratio or the first term. So we have to, bless you, we have to start with the term that's farthest from our first term. So which one would that be? A sub 10. So we have to start with the one farthest from the first term. So a sub 10 is equal to a sub 4 times r to the power of what? So instead of using n minus 1 as my exponent, what would I be using now? 10 minus 4. So let's plug in what we've got. A sub 10 is 125 over 64. A sub 4 is 125 times r to the power of 10 minus 4, which is 6. So everybody see what I did there. All right, so what am I solving for here? R. So what should I do first to solve for r? Got to divide both sides by 125. I can make it 125 over 1. What do I do when I have a fraction and a fraction? Keep, change, flip. So I'm going to flip it to 1 over 125. 125's cancel, so I'm left with 1 over 64. That would be equal to r to the 6th power. What would I do next? I take the 6th root of both sides, because that'll cancel out with the 6th power. We can split this up and find the 6th root of 1 and the 6th root of 64. What's the 6th root of 1? 1. What's the 6th root of 64? 2. Awesome. So our ratio is 1/2. Yeah, you could split it up to help you find the 6th root of each. Because if it's a fraction, you could just see the 6th root of the numerator and the 6th root of the denominator.
From here, though, can't you keep dividing 1/2 from the A sub 4?
You can, but we're gonna do it algebraically and find the formula. So there's a couple different ways we could do it. We know that, what's it asking for? The 14th term. We were given the 10th term, so we could find the 11th. So our 10th term was 125 over 64. How would I find the 11th term? Multiplying by 1/2. And then we could find the 12th term, the 13th, and the 14th. So we could just keep doing that, multiplying by 1/2, multiplying by 1/2, multiplying by 1/2. We're going to do it algebraically. So we're going to come up with our formula and then plug in the 14th term. Because what if this asks us for the 100th term? We can't sit here and multiply 1/2 100 times. So let's find our general formula. So we still need to find what a sub 1 is. So I could say, bless you, a sub 4 is equal to a sub 1 times r to the power of what? If I'm using 4 and 1 now, 4 minus 1. So let's plug in what we have. A sub 4 is 125. That's equal to a sub 1 we don't know yet. What's r? 1/2 to the power of 3. How could I find a sub 1? What should I do first? Got to do the exponent first. So what is 1/2 to the 3rd power? 1/8. You got to cube 1 and cube 2, so 1/8. What would I do next? Divide by 1/8 or multiply times 8. So what's 125 times 8? Nobody seems confident in that answer. 1,000. So our first term is 1,000. So now that we have r and a sub 1, we can plug it into our general formula. So a sub n is equal to, what's a sub 1, our first term? 1,000 times r, which is 1/2 to the power of n minus 1. So this is our general formula. What term does it ask us for? The 14th. So I'm going to plug in 14 into n. So a sub 14 is equal to 1,000 times 1/2 to the power of 14 minus 1. So we get 1,000 times 1 over 8,192. So 1,000 over 8,192, and we can simplify this. Let's see. I'm going to divide them both by 4. Then I can divide it by another 2 here. So we get 125 over 1,024. So here, we could have used a sub 4 or a sub 10, either one, and you'd get the same thing. I picked a sub 4 just because it was 125 and not a fraction. But either one would have worked. If you would have done a sub 10 here, it would have just been 10 minus 1. All right, so today we're going to talk about the sum of a finite geometric series. Finite means what? That it has an end. And then geometric means what? Multiply to get from one number to the next. So our formula for the sum of a finite geometric series is this. Where what do you think a sub 1 is? The first term. What's r? The ratio. N? The number of terms. And that's it. So we just need to know the first term, the ratio, and the number of terms, and then plug everything in. All right, so let's look at example 6. So we want to find the sum. So rather than plugging in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and adding them all together, we can just use the formula. So we need to know what our a sub 1 is. We need to know what our rate is, and we need to know the number of terms. So how do you think I could find a sub 1? So n is equal to 1. 1 is my first term. I'm going to plug that into n, and that'll give me like the first term of the whole thing. So I have to plug in the first number that it gives me here, 1. So I have 4 times 0.3 to the power of 1. So this is just 4 times 0.3. Which would be 1.2. So we just plug in the first number that it gives us. Our rate is whatever the number is that has the exponent. So the rate is 0.3. And then n is the number of terms we have. So from 1 to 12, how many terms do we have? 12. Because we're plugging in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can count them. Or one way to do it would be take the last minus the first, and then add 1. So you do 12 minus 1 plus 1, which would give you 12. So that would only work if it would only help if you started with something other than 1. And if it was really big, and you couldn't just... So you could take the last minus the first plus 1. And that'll give you n. Okay, so let's plug in everything we have. So s sub 12, the sum of our 12 terms here, is 1.2 times 1 minus 0.3 to the power of 12 over 1 minus 0.3. So just make sure you follow your order of operations when putting this in the calculator. I'm going to do 1 minus, and then in parentheses, 0.3 to the power of 12. And times 0.2 times 1.2. So that's the top. So on top, you should get 1.1999. That number. Keep it in your calculator and just do divided by, but put it in parentheses. So you do divided by 1 minus 0.3. So the sum of our 12 numbers is 1.7. We could say 1.714. It doesn't say how many decimals, but we can just keep it as 3. Any questions here? So you just need to find your a sub 1, your r, and your n, and plug it in to your formula. All right, next we have the sum of an infinite geometric series. So infinite, you'll either see the infinity sign at the top of your summation, or it'll ask you to add the numbers and it'll give you the ... meaning that it goes on forever. So the sum of an infinite geometric series, we use this formula. So a sub 1, which is our first term, divided by 1 minus r. R is our ratio. So let's do an example. So for example A, I need to know what my a sub 1 is and r. How would I find a sub 1? What would I plug in to find a sub 1? Plug in 0. You plug in whatever the first number of n that it tells us. So we're going to plug in 0 into n. So I have 4 times 0.6 to the power of 0. What's 0.6 to the power of 0? 1. And 4 times 1 would just be 4. What's our ratio? What's r? 0.6. Awesome. It's the number that has the exponent, so 0.6. So when we plug this into our formula is a sub 1 over 1 minus r. So that would be 4 over 1 minus 0.6, which would be 4 over 0.4, which we can put it in the calculator and get 10. 10 would be the sum. So if we added all of this together from 0 to infinity, it ends up like just keeping decimals, and it just will add up to 10. So 10 is the sum. All right, for B. So because it has this ... it's an infinite geometric series, and we have to find the sum again. The plus signs mean that it's the sum. So we need to know what our a sub 1 is and r. What's our first term? 3. Awesome. It's given right there. How do I find r here? I can divide the second term by the first term. So 0.3 divided by 3 would be 0.1. So then we can plug it into our formula. 3 divided by 1 minus 0.1. We get 3 divided by 0.9. We get 3.33 repeating. So let's do it in fraction form just to see. Well, we can change this so we don't have a decimal in it. Just multiply the top and the bottom by 3, so we'd make it 30 over 9. We'd multiply the top and the bottom by 10. It's been a long day. Multiply the top and the bottom by 10 to get rid of the decimal. And then we can simplify this by dividing the top and the bottom by 3. So we get 10 over 3. I'm not sure how WebAssign wants it. It may say exact answer. Exact answer would be the fraction.